Hello guys, welcome to another mathematics video, and today we'll be learning about Riemann sums, a very nice and easy way to approximate the area under a curve. A Riemann sum is essentially a sum of several rectangles. However, the shape can vary. It could be a trapezoid, it could be something else, but we are using, for convenience sake, rectangles. And it's a sum of rectangles that have a certain known area, and when they're added together, that gives us the area under a curve. However, there is a caveat in that the error could be pretty large, as you can see, for example, in this diagram, depending on how many rectangles you're adding. So over here you can see something we call the left Riemann sum, meaning that the height of each rectangle is determined by the upper left corner of the rectangle. And for each of those corners, we calculate the value of the f of x for every x, and we multiply that by our delta x, which is itself calculated by calculating the difference between point B and point A and dividing that by our desired number of rectangles. Well, obviously, the fewer rectangles you have, the less calculations you'll have to do, and the more you have, the more calculations you'll do. However, the result is going to be much more accurate. As you can see, the error is really slight over here once we've decided to use 12 rectangles. So our delta x is always the same for every rectangle. However, our f of x varies depending on where the upper left corner is. Once we go with more and more rectangles, we start to realize that the sum of all of those rectangles is kind of similar to an integral, and that's exactly the connection between the Riemann sums and the integrals, and it's very well described by this formula here. So the limit of the sum of those rectangles as n approaches infinity essentially equals to the integral of this function on an interval from a to b. And of course, you're not going to have an infinite amount of rectangles to calculate because it's too tedious and you don't need to do that. It's much easier to learn integration. However, for a simple approximation, it can really help. So let's try to put that to practice. And before we proceed, I have to point out that there are two different ways to calculate the Riemann sum: the left Riemann sum, and this is something called the right Riemann sum. And in case of a function that increases on the interval from a to b, the right Riemann sum, where you decide where you go with the top right corner of the rectangle, you get an overestimation, whereas with the left Riemann sum, you get an underestimation for the actual area under the curve. So here we have a function f of x, and we have this interval from 0 to 6. And let's say we wanted to calculate the Riemann sum for this particular interval of this function. So let's try and do that, and we will use both left Riemann sum and right Riemann sum to see what are the numbers that we get and how far they are from the real area under this curve. All right. Now, let's say we want to have our n set to 6 to make our calculations a bit simpler. So if our n equals to 6, that means that our delta x equals to 1. And our Riemann sum, let's say first we will do the left Riemann sum, and that means that the first rectangle is going to start at 0, the second will start at 1, and so on until we reach the last rectangle, which will start at 5. So the formula will look like this. It's 1, since our delta x is 1, multiplied by, and let's start calculating. So we start at 0, and in case of 0, we have 1 plus, then we have 1, and we have 1 and 1/2. And we have 2, so for 2 it's 3. And we have 3, and it's 5.5. And we have 4, and it's 8, so 8 plus 1 is 9. And we have 5, which is 12.5 plus 1, and that gives us 13.5. And if you add all of those numbers together, you get 33.5. And this is the left Riemann sum. Now the right Riemann sum, we just have to subtract this first one that we used and add the last number on our interval, which is 6. So for 6, we get 36 divided by 2, 18, plus 1, it's 19. So let's say we remove this and we add 19 instead, and we should get 51.5. So this is left Riemann sum, and this is the right Riemann sum. Now the actual answer, if you were to integrate this and instead of calculations you decided to go with a definite integral from 0 to 6, the number would be 42. Now you can see that both of those numbers are quite far from the actual area under the curve. However, we are only using the n of 6, and if we desired so, we could use n12 and 20 and so on, and that would bring us closer and closer to the number 42. So that's essentially how it works. However, there's more to it, as there are, as I said, different shapes and other different kinds of approximations. But I suggest you actually use integrals most of the time, and if you want that, stay tuned for more mathematics videos, since we also got that covered, and I'll see you there. Thank you for watching. Bye-bye.